So today we're going to be doing lesson 1 from unit 5. So for your warm-up, we have some bacteria in a dish, and every hour each bacterium splits into 3 bacteria. The diagram shows bacterium in hour 0. So this is hour 0, and this is hour 1. So we are going to draw hours 2 and hour 3. So you can see we have 1 bacterium at the start, and that 1 turns into 3. So for our next picture, this 1 bacterium is going to split into 3. This one is also going to split into 3, and this one is also going to split into 3. Okay? So now we have 9. So how many are there in hour 2? We have 9. And then same thing going into hour 3. Each one is going to split into 3. So this individual one up here is going to be 3. This one up here is going to be 3. And the bottom one there is going to be 3. So all 9 of these came from this one group of 3. So we're going to get 9 more from here and 9 more from here. So go ahead and draw that. Okay, so in hour 3, we will have 27. So every time we go from hour to hour, we are multiplying how many we have by 3. So each time it is tripling. Now here we have example 1. So it says you are walking along a beach and your toe hits something hard. You reach down, grab onto a handle, and pull out a bottle. It is sandy. You start to brush it off with your towel, and poof, a genie appears. He tells you, "Thank you for freeing me from the bottle. I was getting claustrophobic." You can choose one of these purses as a reward. So we have purse A, which contains $1,000 today. If you leave it alone, it will contain $1,200 tomorrow. The next day, it will have $1,400, and this pattern of $200 additional dollars per day will continue. Then we have purse B, which contains 1 penny today. Leave the penny in there, and tomorrow it will turn into 2 pennies. The next day, there will be 4. The amount in the purse will continue to double each day. So, if we're looking at how much will be in each purse after a week, there are 7 days in a week. So for purse A, we would have 1,000 plus 200 7 times. So 2, 3, 4, 5, 6, 7. So this is for day 1, day 2, 3, 4, 5, 6, and 7. And that will give us a total dollar amount of $2,400. Okay? When we have this repeated addition, plus 200, like that, we can also rewrite that as multiplication. So A would be 1,000 plus 200 times 7, because we had 7 days. So that would still give us that 2,400. For purse B, we start with 1 penny, so 0.01, and it's doubling, so times 2 for 7 days. So we'll have times 2, 7 times, okay? That can be rewritten because we have this repeated multiplication here. We can rewrite that with an exponent, so 0.01 times 2 to the 7th power. So that would give us $1.28. Okay. So now for question 2, we're going to kind of answer 2 weeks and 3 weeks here. So for 2 weeks, in purse A, we would have our $1,000 that we start with and add 200 times 14 because there are 14 days in 2 weeks. And that will give us $3,800. And then in purse B, we are starting with our penny times 2 to the 14th because there are 14 days in a week or 2 weeks. And then that would be $163.84. So that's how much we would have in each purse after 2 weeks. And then after 3 weeks, for purse A, we would have 1,000 plus 200 times 21, because there's 21 days in 3 weeks, and that gives us 5,200. In purse B, we have our penny that we start with times 2 to the 21st for 21 days. And in that purse, we would have $20,971.52. Okay? So for our last question here, which purse contains more after 30 days? So initially with 1 week, A had more money than B. In 2 weeks, A still had more money than B. But once we got to 3 weeks, now A had less than B. So after 30 days, purse B will contain more money. Okay? So go ahead and look at the next page. Here we have 2 graphs. Okay, our first graph is here. Okay, that straight line is representing purse A, and that is a linear function. That's what we've been dealing with last semester and so far. The other line starts off kind of flat down here and starts to increase and then goes up all the way like that and continues. That is our graph for purse B, and that is called an exponential. Okay, that's what we're going to be looking at throughout this whole unit. Okay, so we've labeled which graph is which. We can go ahead and skip this question. And if we look at 3, what are the coordinates of the vertical intercept? Remember, the vertical intercept is always our starting. How much did we start with? So for purse A, it will be the $1,000. And for purse B, it will be the penny. Okay. And for when does purse B become a better choice than purse A? When does it have more money? If we look at the graph, we can see all along here, B has less money than A. Okay. Then it starts to get more and more and more and more. And right here at about 19 days is when B starts to become larger than A. You can see that blue dot is just a little bit higher than the red dot. Okay, so after 19 days, the purse B is the better choice. Okay, so then you can answer number 5. Knowing what you know now, which purse would you choose? So go ahead and answer that question and explain your reasoning. And then we'll go over any questions you guys had the next day in class. Hello, everybody. We are going to start today by doing a little notice and wonder. Okay, so I'd like you guys to look at Table A and Table B and write down one or two things that you notice and wonder. Go ahead and pause the video to do this. Once you're done writing, you can share with your neighbor what you wrote down and compare your ideas. Then we're going to look at example 1. So here is one way to think about how much Diego has left after spending $250. And we're going to go through and explain each step. So he starts with $100. So that's what this number here, all of those hundreds, is representing, okay? And he is spending a quarter of it. So in step 1, he has the 100 he started with, and then subtracts 1/4 times 100, which is what he spent. Okay? So it's what he started with minus what he spent. Then in step 2, the only thing we did in step 2 is if you take this 100 that's out front, if we multiply to the 1 and the 1/4, we end up back at step 1. So if we applied the distributive property, we could say distribute / multiply. We'd be back at step 1, okay? That's all that's happening there. Now, step 3 is very, very, very important because the thing that changed is our minus 1/4 has now changed into 3/4, okay? So that means that the 3/4 is how much he still has, okay? So when we're multiplying 3/4 times 100, this is the total amount of money that he still has, okay? Very, very important. That's what we're gonna be using a lot throughout this unit, okay? And then in step 4, all we did was rearrange. So we just changed the order that they were in. Instead of having 100 times 3/4, we just have 3/4 times 100, okay? But this is our big idea here, is thinking about how much are we losing versus how much we are keeping, okay? So bringing us down to number 2, we have a person makes $1,800 per month, but 1/3 of that amount goes to her rent. What two numbers can you multiply to find out how much she has left, okay? This is our big question, okay? She is spending 1/3. I want to know how much she has left after paying rent. So what we can think about is we can take 1 minus 1/3. That's what she spends. So she gets to keep 2/3. Okay? This is the number we want to use. That 2/3 is what she keeps. That's going to be how much she has left. So we can multiply the 1,800 that she makes times 2/3. That's going to be how much money she has left. Then if we look at number 3, write an expression that only uses multiplication and that is equivalent to x reduced by 1/8. Okay, so we are starting with 1 whole x and we are reducing it by 1/8. So if we're starting with 1, reducing means to subtract by 1/8. That means we have 7/8 left over. So this is the number that we're going to use to multiply. So we have 7/8 times x. Okay, very, very important ideas for this unit. When you guys are all set there, go ahead and go to the next page. So here we have value of a vehicle. Every year, after a new car is purchased, it loses 1/3 of its value. Let's say that a new car costs $18,000. A buyer worries that the car will be worth nothing in 3 years. Do you agree? Okay. So if the car is losing, if it loses 1/3, that means it is keeping 2/3 of its value. Okay, so that 2/3 is what we are going to use for our equation because we want to know how much the car is still worth. So we need to know that 2/3 that it keeps. So for year 1, we take that 18,000, multiply it by 2/3, and it is still worth $12,000. Okay. Year 2, we are starting with the $12,000 that it's worth now, and it is keeping 2/3 of that value, which means it is worth $8,000. Okay. Year 3, we are starting with its value of $8,000 times the 2/3 it keeps, and it is now worth $5,333. So that would be its value after 3 years. Okay, so it said the buyer was worried it will be worth nothing. So do we agree with that? No, because it is still worth $5,333. Okay, so we want to write an expression to show how to find the value of the car for each year listed in the table. Okay, and I'm actually going to have us start down here with number 3. Okay, writing the equation first. Okay, so remember back to yesterday or the last lesson, our equation is generally f of x equals a times b to the x. Okay, where a is our initial value, b is our growth factor. So here, our variable for the output is v, and our input is t. So we are going to say v of t equals our initial value, which was $18,000, times the decay factor, which is 2/3 here, that's how much we are keeping, to the power t. Okay, so that is our equation for this problem. Now when we are going to write the equation for the value, we can take all these values for t and plug them in right there. So for year 0, we would have 18,000 times 2/3 to the 0 power. For 1 year, we would have 18,000 times 2/3 to the 1st. For 2 years, 18,000 times 2/3 to the 2nd. 3 years, 18,000 times 2/3 to the 3rd. And now we skip a couple years in here, so we're jumping ahead to year 6, which is totally fine. We're just going to write 18,000 times 2/3 to the 6th. Okay, so we just don't have years 4 and 5 in the table. That's okay. That's just how this table is set up. We could add them if we wanted to. And then for t, we're just going to leave t in there, so we'll pretty much just have our equation. 18,000 times 2/3 to the t. Okay, so that is how we would find all of those values. And of course, these first 3 we found up here in number 1. For number 4, we want to use our equation to find v when t is 0. So we are looking for the output when the input is 0, okay? So we have V of 0 equals 18,000 times 2/3 to the 0, and that just gives us 18,000, okay? So what does this value of V mean in this situation? Anytime our value of T, or that input, is 0, that means that this number is our initial value. In this case, with our context, we're talking about the value of a car. So this is our initial value of the car. Okay? Number 5, a different car loses value at a different rate. The value of this different car in dollars, D after T years, can be represented by the equation D of T equals 10,000 times 4/5 to the T. Explain what the numbers 10,000 and 4/5 mean in this situation. So, 10,000, that would be considered like our A value in our formula if we're thinking f of x equals A times B to the x. This would be our A, that 10,000. So that would be our initial value of the car. Because again, we're still talking about a car in this case. And then our 4/5, that is representing our B value in that formula, which, remember, that is our growth or decay factor. So because we have a fraction here, that is our decay factor. So this is how much value the car has after each year. Okay, that's how much value the car keeps. Okay, so this means it is losing 1/5 of the value. It is keeping 4/5 of the value. And then for question 6, we want to know the value of the car after 5 years. So we can take 5 and plug that in for T into our equation. So we have D of 5 equals 10,000 times 4/5 to the 5th. And if you go ahead and plug that into your calculator, you will get $3,276.80. So that is the value of the car after 5 years. Okay, let me know if you have any questions. Have a good day.